5, we have another situation where we have some sort of a horizontal shrinking or stretching. So let's imagine that this is sine of q is 1 over square root of 2. And if that's the case, we know that q would be in the first quadrant or the second quadrant. And in fact, we know that q here, right, would be pi over 4 plus 2 pi n, any multiple, or q would be 3 pi over 4 plus 2 pi n. However, in fact, we don't have q. We have 3 times theta. So if we want theta, we're going to multiply both sides by 1/3, which is going to give us theta is pi over 12 plus 2 pi over 3 n. And in this case, this is 3 theta. So theta is going to be equal to, multiply both sides by 1/3, pi over 4 plus 2 pi over 3 times n. Now, if we look at what's going on our graph of sine of 3 theta, for sine of 3 theta, we know our period is going to be 2 pi over 3. So our step is going to be, well, I'm going to take 2 pi over 3 and divide it by 4. And I'd rather multiply by 1/4, which is the same thing, and that ends up giving us a step size of pi over 6. So let's look at what this looks like. Step size of pi over 6. So we have pi over 6, we have 2 pi over 6, we have 3 pi over 6, we have 4 pi over 6, we have 5 pi over 6, 6 pi over 6, 7 pi over 6, and 8 pi over 6, which is 4 pi over 3, and let's say 9 pi over 6, which gives us 3 pi over 2. You can even do negative pi over 6. Okay, so let's see what this looks like. So the amplitude is still 1. So when we graph this, we're looking for places where our output is going to be, again, 0.707. So this point over here, I know is going to give me my pi over 12. If I was looking for this location, again, I'm going to use the symmetry. If this distance is pi over 12, then this distance is pi over 12. So I can just take pi over 3 minus pi over 12. The least common denominator is 12, so I'm going to think of this as 4 pi over 12. So that's going to give me 3 pi over 12, which in fact gives me pi over 4, which is exactly what I had gotten before. And then in order to find infinitely many solutions, notice we're going to take pi over 12, and to get the point over here, or over here, we're just going to add the period, but the period we said is 2 pi over 3. So everything is in agreement. Now, for part B, if we're looking for the solutions between 0 and 2 pi, well, 0 and 2 pi, I haven't even gotten to that, but I can tell I'm going to have 1, 2, 3, 4, 5, 6 solutions. So I'm just going to use these. I'm going to start with pi over 12, and then if I add a multiple of 2 pi over 3, and secretly, 2 pi over 3, it's easier for me to think of that in terms of 12ths, so that's 8 pi over 12. So pi over 12 plus another 8 pi over 12 is going to give me 9 pi over 12. If I add another 8 pi over 12, that's going to give me 17 pi over 12. If I added another 8 pi over 12, that would give me 25 pi over 12, which goes over 2 pi. So I'll get rid of that. As far as my other solution, I have pi over 4, okay, and I'm going to add 2 pi over 3 to pi over 4, okay, and I need to find, my least common denominator is 12 again, so this is 3 pi over 12, and I'm going to add 8 pi over 12, okay, so 3 pi over 12 plus 8 pi over 12 is going to give me 11 pi over 12. If I add another 8 pi over 12, that's going to give me 19 pi over 12. And if I add another 8 pi over 12, that would give me 27 pi over 12, which is too big. So there are my 6 solutions.